Welcome and thank you for joining me for this presentation. My name is David Anderson and I'm an independent software developer for Decom Productions, and today I'm here to demonstrate using the MVVM, which stands for Model-View-ViewModel, architectural pattern with WPF. And it is specific to WPF. It doesn't work well with technologies like Windows Forms because the data binding in those technologies are far limited compared to the two-way data binding that WPF provides. So I'm not going to talk a lot about specifics about all the things you can do with MVVM. Instead, I'm going to focus on the overall architectural pattern and what you should do. And throughout the demo, I'm just going to show you how to do things the right way and guide you in that direction, rather than demonstrating the current ways of tight coupling and everything. We're just going to flat out go straight into MVVM. Before we actually dive into the demo, however, let's actually debunk what these three terms mean. None of these terminologies are anything new. Model is just a synonym for entity. It's a customer, it's an order, it's a product. It's basically just your data object. If you're using Entity Framework, all the objects that are generated by Entity Framework, for example, in Database First or POCOs, all of those are your models. So this is nothing new. The view is just a synonym for user interface. It could be something like a user control, a window, even a button. So that's all that means. And view model is just your program logic, your business logic, the actual guts that does all the work. The important thing, though, is to understand the relationship between these three things. The idea behind MVVM is that your view will never talk to anything. It will be completely decoupled. So your view should know nothing about the view model, and vice versa. Your view model should know nothing about the view. And the way we'll communicate between the two is through data binding in WPF. And because their data binding is so powerful, we're not having to actually hard code anything. We can do it purely in XAML. Now, the relationship between the view model and the model is completely the opposite. It's okay to have a strong relationship between the two, directly communicate, but you still want to have the guts of your logic in the view model. And your models should generally be lightweight, have your business logic. Business validation rules would be a more proper way to put it. And then the view model should actually be the guts of, I'm going to load the data, save the data, manipulate the data, take user input, all that good stuff. And the idea behind these relationships in MVVM is that you can swap out your views without any pain. Designers can work with your code without having to, they can work with the views without having to touch code. And it's just a really great pattern. And once you get the hang of it, you'll find that it's actually very easy to make changes to your software. So let's go ahead and jump right in. The first thing we're going to do in our project here, it's just a WPF application. We're going to create our three folders called models, view models, and views. And again, try not to get the terms mixed up. Just think of them, your model as an entity. Just think of your view model as your program logic, and your views as your windows and controls. The first thing we're going to create a customer model, so we're just going to call this customer. And we're going to keep this demo as simple as we can. And we want to implement the iNotify property changed interface, because this is at the core of how WPF does its data binding. It subscribes to events like property changed to update its user interface and things like that. So we're going to create a default constructor for our customer. we're going to take a string parameter called customer name, and we'll have a property called name that we'll create here in a moment. And remember that we want to implement iNotify property change. You can do that via a code snippet. So there's nothing new about this model. It's basically just a plain old CLR object, very lightweight, has a single name property. There's nothing special or MVVM specific about it. So we're done with that. Let's close that out. Let's create our view model. Now the point of a view model is to perform some actions. So you want to separate logical parts of your application. Maybe you want to edit the profile of customers, so you want to be able to edit their first name, their last name, email, things like that. And then you might want to have another component that displays read-only information. You may want to have another component that does something else with the customer. So there's different ways to group your application together. In this case, for the demo, we're just going to create a view that allows us to edit the name of the customer. So for this, we're just going to call this customer view model. And because we need to manipulate a customer, we need an instance of one. So we're going to create a property for that. And normally you would maybe populate this by loading it from a database, maybe an XML file, wherever you're storing your customers. Since we're doing a very simple demo and we want to keep it lean and to the point, we're just going to do this in the constructor. So we're going to set the value of our customer to a new customer, and I'll pass in my first name to the constructor. And then some of the other functions of the view model is, well, if we want to update the properties of the customer, we want to be able to save those. So we want to create a function called save changes. And because we're doing this in theory, I'm just going to use a debug assertion to display a dialog. Okay. So we have our basic logic. We have the ability to access the customer properties, so we can update the customer's name, any other properties we want to add in the future, and then we can call the save changes method to persist the changes to our data source, again, in theory. So now we actually need the user interface to be able to do all this. We're going to create a window and call this main window. Okay, so we have just a very simple form with a label, a text box, and a button. Now we need a way to get the data from our view model into the view, and we're going to do that through data binding. And it's primarily done through the data context property, the window. And this is really one of the only times you want to write anything within the code behind of your view. And this is okay. And you also need to remember that MVVM is not a solve everything pattern either. There are times when MVVM is not the right thing for the job, and you need to be aware of when those things happen. It's okay to break the pattern. Most of the time you probably won't need to do that, but for the example of like setting a data context, this is okay. So we're going to set this to a new instance of our customer view model, and that's it. Aside from that, we should never have to write any code in the view. Now what we can do is for our text box, we can set the text property to binding on the data context as our data source, and we can set it to customer.name, and if we run this, we should get a value of David. Oops. Main window. Oops, I accidentally created the window in the root. Update the namespace. There we go. So we should get a value of David. Oops, I did it again. We need to move that to our views folder. So we should get a value of David in the text box. So we're able to retrieve the value from our view model, and we did that without hard coding anything. So let's go ahead and close that. And now we need a way to actually update the data. Now normally you could use the click event for a button, but that would create coupling. Not only would we have code in the code behind of our window, but we would also have to write code to access the view model, which couples the window to the view model. So instead, we're going to use WPF's command system. So you can say command equals binding, and we're actually going to specify an update command on our view model. So we're going to bind again to the data context, which is set to an instance of our view model, and we are going to bind to a property called update command. And in our view model, we are going to create a property called public iCommand, and we'll create our command here in a second, and this will be called update command. And in our constructor, we're going to say update command equals new customer update command. And what we're actually going to do is create a command that implements the iCommand interface called customer update command. So we're going to add a new folder in our project called commands. And we'll add a new class. Now the immediate things we need is to derive from iCommand. And we also need access to our view model. So in the constructor of the command, we're going to say customer view model. And let's go ahead and implement the iCommand interface. And there's three main pieces to this. There's the can execute changed event. Now because we're implementing the interface directly and we're not deriving from some already concrete type like routed command or anything like that, we need to wire this back up to the WPF command system. So we're going to do add command manager, requery suggested, and we're just going to pass off our events to the command manager. So now we're wired back into the WPF command system. And the can execute method, this is actually used for controls. For example, our button will enable or disable itself based on the return value of this method. So what we're actually going to do, instead of putting business logic in the customer update command class, we're going to pass this off to our view model. So we're going to say return view model can update, and we're going to create a property stub in our view model. And then for execute, we're just simply going to call viewModel.SaveChanges. So now we're done with our command class. Let's go back to our view model and grab our property stub. And now we can import our commands namespace. And pass in an instance of our view model, which is just done using the this keyword. Alright, so now we can go to our main window and let's go ahead and run the program. And you can see here that our update button is disabled, and that's because we didn't actually add any logic to our can update property, and the default of a property or field for a Boolean value is false. So let's go back to our view model, and we'll make this read only, and we'll say return not string is null or white space, and we'll say customer.name, and then we'll say if customer is null, return false. So if our customer is null or not set, we're going to say we can't update something that doesn't exist. And then if the user, or excuse me, the name of the customer is empty or null, we're also going to say we can't update. So if we run this now that we have some validation logic in there, you can see that our update button is in fact enabled, and as I update the value of the text box and click the update button, you can see that now that the text box is empty, the update button is disabled and it did not execute. Now realistically, we want the update button to enable or disable as we're typing text, because the way the default binding behavior is that the underlying data source does not update until focus is lost from the text box. So that's why the update button didn't disable until I clicked it. So we can change that by going to the XAML, and we can go to our text box binding and say update source trigger equals property changed instead of lost focus. And we can run this. And if I erase the text, you can see that it disabled as soon as it detected there was no characters, and as soon as I type a character, you can see that it's enabled again. So I can set the name to David Anderson, and I can click update, and what that does is it calls the update command can execute method that we implemented in our command class, and you can see that our debug dialog was displayed, and all our can execute method did was call through to our view model to the save changes method, and you can see that it's displaying the new value in our debug assertion. Now if we go back, and we're actually done, if we go back and look at all this, our XAML is very clean, very simple, and in the code behind of our window, we never touched it other than setting the data context, and there are ways to remove that. You don't have to set the data context in the constructor. You can instantiate your window yourself and set the data context that way, so you're not actually accessing any of the code of the window. So you don't have to do it this way, but this is acceptable for MVVM. The whole point is that for everything else, you're not writing code in your code behind. If we go back to our view model, still pretty simple, but this is where it's okay to have a very heavy view model. So throw all your logic in there, properties, methods, events, and then for your models, they should generally be lightweight. So you can already see that the power of this pattern is, we can go into our window now. Let's close everything else. And I can modify the user interface. I can say, I can move stuff around. And I don't have to touch any code to change our user interface now. I could even change the type of controls that these are, and it won't break the code. So I can change let's see, text box. We could change that to an editable combo box if we wanted to. And if we were to run that, we can see that we can change the text of the combo box. And we didn't have to change a single line of actual code to change the user interface. And that is the power of the MVVM pattern. Now obviously that MVVM can get complex, especially if you're dealing with large systems. So I will be making more instructional videos come in the future, so look forward to those. But for now, I wanted to get the basics of it out there. And if you have any questions, as always, post in the comments, post on my blog, email me. Everything is great. So thank you for joining me for this presentation, and happy coding.